Welcome to Spring LIB.
Okay, so we're given the kinetic energy and momentum of a particle, and using those, we have to figure out its mass. So here we use two equations. Equation 26-6a, which says that energy equals kinetic energy plus rest mass energy, which is mc squared. Let's call this equation 1. Good. Then we use equation 26-9, which is also an equation of energy, but here it's an E squared, which is equal to P squared, momentum squared, times speed of light squared, plus m squared c to the fourth power. Let's call this equation 2. And here we note that squaring equation 1 will lead to equation 2 because you have E squared on the left-hand side for both of those. So let's see that in action. E squared, squaring equation 1 means you're squaring this number over here, ke plus mc squared. So if you remember from high school algebra, that 1 plus b squared can be expanded to, a plus b squared can be expanded to a squared plus twice ab plus b squared, right? And so that's what we're going to use here to expand this out. What we get is E squared is equal to ke squared plus 2 times ke times mc squared plus mc squared quantity squared. So this just comes out to m squared c to the fourth. Okay? So what we have then is that ke squared plus 2ke times mc squared plus m squared c to the fourth is equal to p squared c squared plus m squared c to the fourth. And so the m squared c to the fourth terms cancel out, and you note that the only mass we have is in here, so we can make that the subject. Mass is what we want, right? So make m the subject, you get m equals p squared c squared minus ke squared on the numerator divided by 2 times ke times c squared on the denominator. Okay, so let's work that out. M is equal to p squared, which is 121 MeV per c squared times c squared minus minus squared the kinetic energy, and so that's just 45 MeV squared. Note that the c's here cancel, the c squared and the denominator and the c squared in the numerator, so you're left with MeV squared on the numerator of this whole thing. And on the denominator, you have 2 times, once again, kinetic energy, 45 MeV times c squared. And so this gives you 12616 over 90 c squared, because the MEVs cancel, and you're left with 140 MeV per c squared. And so you can leave your answer as this. This is obviously a way of quoting mass instead of but if instead you want your mass in kilograms, you will have to use the fact that 1 MeV equals 1.6 times 10 to the negative 13 joules. And so that's in SI units, which contains kilograms, meters, and seconds. And speed of light in SI units is 3 times 10 to the 8 meters per second. So you plug those in there, and you get that mass. And so you multiply 140 by this factor here, and you divide that whole thing by this thing c squared. And what you get out of that is mass is very close to 2.5 times 10 to the negative 28 kilograms. And that's it.